Dear students, I am Angad Naik, Assistant Professor, Department of Mechanical Engineering, SGBIT, Belagavi. I welcome you all to Module 4 on CAMS Session 1. First, let us have a look into the syllabus. Classification of CAMS, types of followers, CAM nomenclature, follower motion and motion analysis of simple harmonic motion, then motion with uniform acceleration and deceleration, that is UARM, then uniform velocity, then cycloidal motion, then the cam profile with offset, knife edge follower, roller follower, flat faced follower. All this are there in the syllabus. Let's see the contents. First, we will begin with the definition, terms and classification of types of cams. Then we'll focus on the types of followers. The cam is the red part that you see on the right hand side figure, and the vertical structure is follower. Then we will be discussing on displacement diagrams, then velocity and acceleration time curves for cam profile, then follower motions. They are of various types. One animation you can visualize on the right hand side. The follower motions are uniform acceleration and retardation, UARM, then simple harmonic motion, then uniform velocity, last one cycloidal motion. Let's see the definition of a cam. Introduction. A cam is a rotating machine element which gives reciprocating or oscillating motion to another element known as follower. So in the previous slide there was an red part which was cam and the vertical structure is follower. We'll visualize an animation on this. The red center of rotation, red part which is rotating is the cam, and the part which is lying on the surface of the cam is flat follower, which will slide or reciprocate in vertical motion because of the profile of the cam. So cam is a rotating machine element which is giving reciprocating or oscillating motion to another element. That another element is follower. Now in this particular animation you can see the reciprocating motion. The cam may be rotating or reciprocating, whereas the follower may be rotating, reciprocating or oscillating. So all these three are possible for follower, but only two are possible for cam, that is rotating or reciprocating. There are few elements of a cam mechanism. First one is a cam, which is a driver member. Second one is a follower, which is a driven member, and the frame which supports the cam and guides the follower, that is the frame. A cam and the follower combination belong to the category of higher pair. This is in relation with the module 1 where we discussed about lower pair and higher pair. Let us see how these cams are manufactured by different processes. Cams are manufactured by die casting, milling or punch presses. A cam has two parts, as visualized in the animation. It is follower and the cam profile. Now we'll have a look of diagram which will make us help us in understanding the type of motion. Diagram number 1, 2, 3, 4, 5, 6 are shown. Diagram 1 to 6 shows a rotating cam pushing a follower up and then allowing it to slowly fall back down. Now we'll analyze one by one. In diagram 1, the cam is in vertical position. So the cam is in vertical position and it slow rotates in an anti-clockwise direction. So this direction is anti-clockwise direction. So this has started rotating anti-clockwise direction. As it rotates, the follower drops down. So as this is continuing to rotate anti-clockwise direction, you can see the height of the follower, it is falling down. So the follower is dropping down. In diagram 4, the follower is in its lowest position. The cam continues to rotate and the follower begins to rise as it further rotates in diagram 5 and 6 until it returns to its original position. Original position is this diagram 1. So we started with 1 where there is anti-clockwise rotation of the cam. This is continued from diagram 1 to 6 wherein it attains its original position by the one revolution of the cam. Let's see the application of cams. Operating the inlet and exhaust valves of IC engine. So this will understand with the animation. So at the bottom you can find there is cams. These are the cams which are connected to the follower. The follower are connected to the puppet walls, and these opening and closing of the wall is controlled by the profile of the cam. Automatic attach of machineries. There also we find the application of cams. Paper cutting machines, spinning and weaving textile machineries, feed mechanisms of automatic lathe. All these are the applications of lathe. The same animation of inlet and exhaust valve can be seen in another animation. So we'll have a look of another animation. The actual burning process of the fuel by power stroke can be visualized. Let us see the example use of a cam. Now in the figure you can see there is a toy whose shoulder is moving up and down. This is because of the cam is rotating and the follower is reciprocating and the arm is lying on the follower. Because of this there is vertical motion possible. A simple toy is controlled by a cam and follower. As the cam rotates in anti-clockwise direction, the follower falls. It is in the diagram 2, it is falling down. So here it is falling down. And so does the arm of the toy. As the cam continues to rotate, the arm begins to rise, seen in figure 4. So in figure 4 you can see the arm is rising up. The shape, the cam shown is a pear-shaped cam named after its shape. We'll take another example. In this particular animation, you can see the robot is able to make a movement because of pear-shaped cam. The cam seen in animation is a pear-shaped cam. As the handle is turned, the handle is here. If you rotate this handle, the cam also rotates because the handle and shaft along with the cam all are in the same axis. The model moves forward and backward as a result of the profile of the cam. The movement is gentle, although the faster the handle is rotated, faster will be the motion of the model. So the more speed with which you rotate this, faster will be the movement of the model. We'll take a look of classification of follower. These can be classified into various bases. First we'll see according to the surface in contact. Now the first one among surface in contact is knife edge follower. The knife edge follower is seen in the right side figure. It is called as point or knife follower. When the contact end of the follower, so this is the contact end of the follower, has sharp knife edge, it is called as knife edge follower. This can be seen in the figure. The sliding motion takes place between the contacting surface, that is the knife, and the cam surface. You can see in the animation as the profile of the cam is rotated, the follower makes vertical or reciprocating motion. It is seldom used in practice because the small area of contact surface results in excessive wear. In knife edge follower, a considerable side thrust exists between follower and the guide. Let us see next type of follower. Second one is roller follower. A roller follower will look like this. There is a roller which is having circular end, which is rolling on the surface of the cam. A 3D model will look like this. When the contacting end of the follower is a roller, it is called as a roller follower, as shown in figure. We'll see an animation. The roller is following the profile of the cam. Since the rolling motion takes place between contacting surface, therefore the rate of wear is greatly reduced. In roller follower, also the side thrust exists between the follower and the guide. The roller follower are extensively used where more space is available, such as stationary gas and oil engine and aircraft engines. Let us see the next type of follower. The name is flat-faced or mushroom follower. Figure you can see on the right hand side. So the follower is flat end. So because of this flat nature, it is also called as mushroom follower. When the Contacting end of the follower is a perfectly flat face. It is called flat faced follower as shown in the figure. It can be noted that the side thrust between the follower and the guide is much reduced in case of flat faced follower. In fact, the only side thrust is due to friction between the contact surface of the follower and the cam. These are generally used where space is limited, such as in cams which operate the walls of a automobile engine. However, when the flat-faced follower is circular, it is then called a mushroom follower. This should be noted. Now we'll see the animation for flat-faced mushroom follower. So this is a flat-faced follower. Let us now look into the next type of follower, that is spherical faced follower. The spherical faced follower is shown. This shape is spherical. This shape is spherical. So spherical faced follower. The first one is cam with spherical faced follower, wherein the motion is like this, and here it is like this, where there is not direct follower which is right upright. It is slightly hinged at a point, and then the end is lying on the surface of the cam. When the contacting end of the follower is of spherical shape, it is called as spherical faced follower. It can be noted that when a flat faced follower is used in automobile engine, high surface stress are produced. In order to minimize these stresses, the flat end of the follower is machined to a spherical shape. These are the four different types of follower under first category. Let us go to the next, according to the motion of the follower. Among this, the first one is reciprocating or translating. The name itself says the follower is reciprocating. When the follower reciprocates in guides as the cam rotates uniformly, it is known as reciprocating or translating follower. The animation will look like this. So figure is like this, whether it is knife edge follower, roller follower, or flat faced follower, all these types are involved in reciprocating or translating follower. The followers as shown in figure A to C are all reciprocating or translating followers. Let us see the next type, oscillating or rotating follower. First we will see the animation and then proceed. So in the animation it is obvious that the type of follower is oscillating when the uniform rotary motion of the cam is converted into predetermined oscillatory motion of the follower. It is called oscillating or rotating follower. You can see in the animation the follower is oscillating or rotating follower. Let us see the next category of classification, that is based on path of motion of the follower. In that, the first one is radial follower. In all these followers, you can see the axis of the cam and axis of the follower are in same line. Here also they are in same line, same axis. In this also you find they are in same axis. So when the motion of the follower is along an axis passing through the center of the cam, it is called as a radial follower. From figure A to C, all are examples for radial follower. Now if they are in the same axis, it is radial follower. If they are in different axes, then it should be offset. So second type is offset. The figure looks like this. A to D are all offset. See, the axis of the cam is this, axis of the follower is this. There is small gap between the axis of the cam and axis of the follower. This is same in all the four figures. So the common statement is, when the motion of the follower is along an axis away from the axis of the cam center, it is called offset follower. So let us now have a look of cam profiles. Cams can be shaped in any number of ways, and this is determined by the way the follower is to move. So based on the type of follower motion, the type of cam is selected. The shape of cam is called as profile. There are various examples of cam profile like this, and each one is named according to the shape. Let us see one by one. First one is the pier shaped cams are used on the shafts of cars. The follower remains motionless for about half of the cycle of the cam, that is, when it is rotating from this point to this point, the radius of the cam is same, so there is no motion from this range to this range. The moment it rotates in this part, there is motion for the follower. So during the second half it rises and falls. Second one is the circular cams or eccentric cams produce a smooth motion. These cams are used in steam engines. Third one, the shape itself says heart shaped cams. This allow the follower to rise and fall with uniform velocity. The last one is the drop, wherein there is sudden reduction in the cross section, so there is reduction here. So if the cam is rotating anti-clockwise, it will gradually, so there is gradual change in the diameter, and only in this part there is sudden change in the radius. So drop shaped cams allow the follower to increase progressively and suddenly drop vertically downward. So the anti-clockwise rotation of the cam will do the needful. Let us see the eccentric cam. The name itself says that it is away from the center, so the eccentric cam. An eccentric cam is a disc with its center of rotation positioned off center. This means the cam rotates and the flat follower rises and falls at a constant rate. This type of cam is easiest to make, and it is one of the most useful. So you can see this in the figure. From diagram 1 to 7, the cam rotates in anti-clockwise direction. As it rotates, it pushes the flat follower upward. So here the flat follower is in the bottom. It rises and reaches to highest. As it rotates, it pushes the flat follower upward and then allows it to drop downward. The movement is smooth and at a constant speed. So the anti-clockwise rotation of the cam will first rise and then make the follower to fall down. Let us have a practical example of eccentric cam. This is a mechanical toy based on a series of eccentric cams. So these series of eccentric cams, these are all series of eccentric cam. If this handle is rotated, you can visualize the movement of the mechanical toy. As the handle is turned, the shaft and the cams fixed to it rotates. Placed above the cams are a number of segments representing a snake. As the cam rotates, some part of the flat follower are pushed upwards while the others drop down. This gives the impression that the snake is moving. We'll take up another example. In this, the eccentric cam below pushes the fish upward and allows it to drop downward at a uniform speed. The overall speed is controlled by the speed of the handle. The faster the speed of handle rotated, faster will be the motion of the fish. The next one is snail or drop cam. We'll see the animation first. The cross-section area of the cam increases gradually and suddenly there is reduction in the radius. So eccentric, heart-shaped and pear-shaped cams generally allow for a slow rise and fall of the follower. However, a snail or drop cam is used where the drop or fall of the follower must be sudden. The example of drop cam shown opposite rotates in anti-clockwise direction. Rotating in clockwise direction would probably lead to entire mechanism jamming because the part which is dropped will obstruct the rotation of the cam. This highlights one possible disadvantage of using this type of cam profile because of this jamming problem when it is rotated in clockwise direction. Also, to ensure the rotation is smooth, the vertical center line of the snail drop cam is positioned slightly to the left of the slide. So it is positioned slightly left of the slide. We'll see the series of diagram from 1 to 7. It shows the rotation of snail or drop cam. When rotating for one complete revolution of the follower stays level for approximately first 120 degrees, that is from diagram 1 to 4. The follower then rises slowly, that is from figure 5 to 6, and then suddenly drops when it reaches and passes the peak. We'll see a practical example of snail or drop cam. Now there is sudden drop of the cam which makes the follower to rise gradually and drop suddenly down. The follower is attached to the ankle of the toy and this makes the motion from the fork to the mouth. The food is being transmitted. So the mechanical toy seen below has a snail cam as its main part. The follower is connected to the character arm by a wire link. As the cam rotates, the follower rises and the wire link lifts the character arm. This gives the appearance of the character lifting a fork full of food towards his mouth. As the cam continues to rotate, the follower suddenly falls and also the character's arm and fork will also drop down to collect next food for to be connected to the mouth. Next is the flat plate cam, which is also called as linear cam. First we'll see the animation. In this particular animation there is flat plate cam. It is a basic example of flat plate cam. So we'll see the another animation. Now what is evident is as the flat plate cam profile moves to the left, the follower moves up and down, matching the shape of the profile which is at the bottom. The flat plate cam then reverses in opposite direction and the follower drops and rises again. So we'll take another animation. A more sophisticated example of flat plate is as shown above. The follower is unusual because it has a roller wheel to help the smooth movement of the flat profile cam and the follower. It has also a return spring that pushes the follower against the profile, ensuring that it always runs against it and follows the shape precisely. Now we'll take an example of a machine where this can be used. The main spring returns the entire mechanism to its original position. So there is machine seen below is a mechanical paper punch. As the lever is pushed down, so as it is pushed down, the gear system called a rack and pinion. So this is the rack and pinion moves the flat plate profile to the left. In turn, this pushes down the followers, which punch two holes in a piece of paper. So this is what happens in a paper punch. The edge of the flat plate cam can be shaped to give different vertical movement of the cam follower. The linear cams are used frequently in machines that carry out the same repetitive movements again and again. Next we'll have a look of unusual cams, that is the cylindrical cam or barrel cam. We'll first see the animation and then go to the explanation. In the animation, it is evident that as the cylinder cam profile rotates, the follower moves upward. When the follower reaches the top, the cylinder cam rotates in opposite direction and the follower moves back. See, it is moving back. So this is a figure of cylindrical cam. These unusual cams are normally composed of a cylinder. Cylinder is this one is the cylinder, which has a groove. See, this is the groove which is cut on its surface, and it is in this that the follower runs up and down. This type of cam can be seen in some old clock mechanisms and in modern sieving machines. Machines that perform repetitive movement may use a cylinder cam profile. Now we'll have a look of two cylindrical cam, one with reciprocating follower, the other one with oscillating follower. We'll have a look of animation wherein the same is used for vertical motion of the forks. The forklift truck seen below has forks that rise and fall. This is a basic design requirement as the truck is designed to lift and move heavy weights, objects. A mechanical system based on a cylindrical cam and follower that controls the vertical motion of the forks. Let us look into some of the key phrases. First one is one cycle. One complete rotation of the cam is called as one cycle. Dwell, when the cam rotates but the follower does not rise or fall. So for full rotation of the cam, when there is no displacement occurring in the follower, then we call it as dwell. Next one is the rise. When the motion of the cam makes the follower to move up is called as the rise. According to the follower movement, we can divide them into motion of the followers are distinguished from each other by dwells they have. A dwell is the zero displacement or absence of motion of the follower during the motion of the cam. So we'll classify them based on this. So the first one is rise, return, rise, denoted as RRR. The figure looks like this. Cam angle from 0 to 360 is plotted in XY direction. On y-axis there is follower displacement, so the displacement of the follower is in this direction, and rotation of the cam from 0 to 360 degrees on this axis. So there is rise, return, and then again the same pattern is followed further. So that is rise, return, rise. In this there is alternative rise and return of the follower with no periods of dwell. You cannot see any dwell in this figure. Its use is very limited in the industry. The follower has a linear or an angular displacement. Now we shall see the next one, that is dwell, rise, return, dwell. So there is dwell in the beginning, then there is rise, then there is return, and then again there is dwell. So this we call it as dwell, rise, return, dwell. In such a type of cam, there is rise and return of the follower after a dwell. This type is used more frequently than RR type of cam. Next one is dwell, rise, dwell, return, dwell. So there is dwell, rise, dwell, return, and then again there is dwell. It is the most widely used type of cam. Dwelling of the cam is followed by rise and dwell. So here there is dwell, and there is dwell, and then we have rise and return, and subsequently by return and dwell as shown in figure. In case the return of the follower is by a fall, then the motion may be shown as dwell, rise, dwell. Now we have come to the end of the session. Hope you have understood. Thank you for watching the video.